This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi, welcome back to Father-Offspring Interviews. Our first question for today's episode from Dee from Sioux City, Iowa is, do we know anything about the evolutionary history of autism/ASD? Is it a disease of modernity or perhaps something that's been around for a while and is just being expressed differently now?
First, D from Sioux City, Iowa. Sioux City, the place, Rugula, where your grandpa Sid was born and raised. And you remember we went and visited his childhood home in Sioux City. So delighted to hear from Sioux City. Delighted to hear follow up on Tylenol, autism, its biological roots. And this one is taking a longer perspective, asking where does this variant on human neurodevelopmental trajectories come from evolutionarily? Do we have one of those? Oh, it used to be adaptive and it's less so now. Is it something that never existed in the past and is a measure of modernity? Really interesting work done recently, a recent book, well timed, that I just finished reading by Simon Baron-Cohen called The Pattern Seekers. Simon Baron-Cohen, professor at Cambridge in the UK, one of the world's experts on autism. This was a recent book of his looking at the evolution of autism. And basic punchline was something dramatic happened to human cognition about 70 to 100,000 years ago. Humans became systematizers, and we will get to more details about that. And an extreme subset of humans were hypersystematizers, and a subset of them have been people who ever since have been labeled as being on the autism spectrum. And what you see is that these have been the inventors. These have been the people who have done a lot of leapfrogging of human progress. Okay, so the whole starting point is autism spectrum disorder on a continuum. And Baron-Cohen's point, one key point throughout the book, is all of these are traits on a continuum. There's a continuum between at one extreme, people who are highly systematizers in their thinking. They look for patterns. They gain comfort from. They use patterns to infer if-then clauses, to use it to generate variance, to use it for recursive thinking. So at one extreme, systematizers, and at the other extreme, people who are instead much more oriented towards empathy, feelings, all of that. Now, the empathizing circuit, as Baron-Cohen calls it, is something that has clearly been around for a long time, way predating humans. We are not the only species that shows pretty convincing evidence of empathy. Chimps, other non-human primates, rodents, rudimentary versions. So it is older than that. What is more recent, what he would say the last 100,000 years or so, is humans not only being good at what we would call affective empathy, but also at cognitive empathy, understanding somebody's different feelings than yours are rooted in them having different thoughts. Theory of mind, we're not the only species with it, but we've got a much fancier version. So that's at one extreme. And his emphasis has been at the other extreme of this systematizing mechanism that emerged in humans about 100,000 years ago. What that's about, hang on for a moment, but it is this whole pull towards looking for patterns that tell you about underlying causality, patterns that tells you about the if-then clauses that explain this phenomenon, patterns that allow you to experiment to see if you could make this better, that allow you to experiment systematically. And his point is this really was not around more than 100,000 years ago. You do not see evidence of this in non-human primates. You see tool use, something we've talked about. Chimps make tools, other primates make tools. You don't see incremental advances over time. People have found ancient chimp tool sites, and it's the same tools that they make today. There's not an incremental advance, an increase in the complexity. There's not invention. And there's not invention that implies that there was systematic experimentation with variants. You don't see this with chimps. As someone in the field, Daniel Povinelli, has said, chimps are able to work only with the observable. They are not able to infer underlying causal mechanisms. So this is very uniquely human. You don't see this in other hominins. You don't see it in Neanderthals, for example. What's the evidence in humans, Homo sapiens, starting 70 to 100,000 years ago or so? You see a sudden flowering of technology, a burst not only in tools, which had been around long before that, and starting with chimps, but you see the first evidence of incremental advances in the complexity of tools. You look 10,000 years later and they're fancier tools. They start showing regional differences. They start showing, most importantly, tools that have multi-part components. And the crowning example for Baron Cohen in this is the emergence 80, 90,000 years ago of bows and arrows. Spears have been around for a long time. Chimps make something resembling spears. They don't throw them. They're not at the point of understanding the causality of, if I do this and send this hurtling, trajectories, physics, gravity, Newton's apple, whatever, will result in it going into that individual or that animal. They use it to poke at animals that are hiding in trees. Spears, you saw that in humans in the conventional sense earlier than 100,000 years ago, but then suddenly you see bow and arrows. And think about the different steps involved in the invention of a bow and arrow. It's multiple parts. It's component to each of the parts, the stick on the arrow and the pointy part and the feathers you put at the back and the bow, and the bow doesn't come as is, but you have to modify it, you have to bend it, and then there's that vine thing you got to tie on. And then there's the combinatorial business of, oh, you do something with the arrow and something with the bow, you put them together. And the main point is, how did people figure out how to use this? By the time you start getting technology, objects, material objects that reflect a systematizing mindset, what you see is you couldn't have come up with this thing without coming up with a whole bunch of failures along the way. You had to be systematically trying different versions. And Baron Cohen makes a great deal of this famous quote from Thomas Edison that completely captures the sense of this, where he said, when you try something and it fails, when I failed to figure out how to make a light bulb for a long time, I had not failed. I had discovered 10,000 ways that would not solve this problem. And when you start having humans making bows and arrows, they had to have gone through a lot of different versions that didn't work. No evidence of any other species doing debugging, doing systematic testing with things that don't work, but I'm just going to push towards this. Okay, so that's very cool. That's very cool. And what Baron Cohen begins to emphasize is, somewhere along the way, as we have this distribution of people who are strongest on empathy, people who are strongest on systematic, logical, sequential thinking, as you get people at that extreme, not only did we evolve humans who were good at that, these hyper systematizers, but critically, we got humans who liked doing that, who took comfort from doing that, who fled the empathic end of the human continuum, the human distribution of sort of cognitive styles, and liked being this way. Humans who sought out patterns, humans who derived pleasure from it, humans who wanted to systematically explore the parameters of these patterns, humans, I think, most insightfully sort of stated by Baron Cohen, humans for whom truth and predictable patterns equal comfort, equal a sense of this is how the world works, where you sit there and, as is typical of many individuals with more severe autism, where they can sit for hours spinning the wheels on the tires of a toy car. Oh my God, what's that about? You spin it, and each time it comes back to the same place. It doesn't go spinning off. It doesn't suddenly express emotions to you. It doesn't fly. You do this, and this pattern is repeatable. The comfort of repetition, the comfort of then being able to explore the boundaries of these predictable patterns to begin to incrementally advance stuff, to invent. And one of the things that Baron Cohen does very convincingly in the book is shows that a lot of our most famous inventors, Thomas Edison being the best example, when you look at the details of their personal lives, their personalities, there was every reason to think that they would now be characterized as being on the autism spectrum. There's all sorts of measurement instruments by now for looking at where somebody falls on the empathy circuit scale, where somebody falls on the systematizing scale. And big surprise, most people wind up somewhere in the middle, a combination of the two. And what you also see as a theme is that you don't see people with a whole lot at one extreme and a whole lot at the other extreme. It's one or the other. So what's the evidence for making this an actual relationship? And what he cites in there, and I wish he had back this up with a little bit more rigorous genetic data, but there's an overlap between hypersystematizers, people who come out the strongest on these surveys. I like understanding how things work. Do you disagree? Do you moderately disagree? Do you strongly agree? I like seeing how things work. When something is broken, I like to take it apart. When I see a chair, I think about how it was constructed. When I hear a piece of music, I can hear the patterns in it. These are the signs of someone in the direction of systematizing. And when you look at the hypersystematizers and you look at their genetic profiles and the genetic profiles of individuals on the autism spectrum, there's a considerable genetic overlap. And there's a dramatic lack of overlap with the people who come out way at the empathizing ends. And this comes through in one other way, occupations that call for a very systematizing mind, classically engineers, computer programmers, Silicon Valley as ground zero of the systematizing mind. And what you see is a covariance of autism spectrum individuals and individuals in hypersystematizing professions. For example, Silicon Valley engineers, going back 2 generations, their family members have more than double the likelihood of being on the autism spectrum. So his basic theme was we're seeing normal human variability. We're seeing advantages at the extremes. The extreme of systematizing is a fairly recent thing in human history, and it is the engine of innovation. It is the engine of what made for the cognitive revolution in humans, which is the ability to systematically experiment and systematically, incrementally advance the complexity of things. This is a critical step towards human advancement. Now, implicit in that are two ideas. One is something that population geneticists call frequency-dependent selection. And I've already referred to this. Yes, it's great to have variability in a population. You wouldn't want to have a population of nothing but Google programmers, nor would you want to have a population of nothing but poets. You want to have a small percentage of each. The more prevalent they become, the less unique and advantageous the trait is. And this is a property with a lot of traits. So there's been selection against either overflowing into the general human population and instead frequency-dependent selection. The other is this theme of heterozygotic vigor, which is to say a lot of these traits in the mild forms are highly advantageous. And this is his world of systematizers as having been the engine of human advancement. This is also the world of poetic individuals doing great things for our souls. And there has been selection for a certain frequency of them. And given how genetics works, which is you have a moderate expression of a genetically influenced trait, you will have with a lower frequency extreme versions among the cousins, what we would see as the most incapacitating versions of autism spectrum as being the rarest outliers of what is otherwise one of the traits that at a low rate is selected for in humans. Okay, so all of that is great. One last complication with this, which is some episodes ago talking about the findings of some sort of linkage between the Neanderthal genome and the incidence of being on the autism spectrum. And this was very, very indirect genetic evidence. This was showing that people on the spectrum, on the average, had a higher percentage of their genomes that were Neanderthal derived. These are European populations, not any one particular gene, any one particular set of genes, but just this is something suggestive. This is 40 to 60,000 years ago, long after Baron Cohen's supposed emergence of human systematizing spectrum-like extremes. No resolution to this. And this book of his is quite recent, and I was disappointed that he didn't address that.
Next, Stephen Bezruja from Seattle says, you discussed two types of obesity, central or apple-shaped, and gluteal or pear-shaped. The former was worse for health in having more inflammation. People speak of metabolically healthy obesity, namely you can be healthy at any size. What are your thoughts on this? Does it apply to the gluteal forms?
First off, we're giving Stephen's last name atypically because delighting me to see this question. Stephen Bezrucha is one of our most esteemed public health mavens in the United States. He's a physician, professor at University of Washington. He is one of the leaders in trying to make sense of why Americans are so damn unhealthy, trying to make sense of we spend more money per capita on healthcare than any other country on earth, yet there's approximately 40 other countries where people live longer, where there's lower infant mortality rates, where there's lower maternal mortality rates. What's that about? And what he's explored for years is it's in part driven by poverty, but much more importantly, driven by inequality and how that is baked into the American system. He has a great book that's coming out in February, which is called Born Sick in the USA. And it's about as depressing as it sounds, except he manages to get a little bit of optimistic news at the end. So very pleased to see a question from him. What this harks back to is a number of episodes ago talking about this bizarrity that your fat tissues not only contain fat cells, but contain inflammatory cells. Inflammation, fat could be inflamed. What's that about? We went through that. There are indeed inflammatory cells within your fat, and reflects one of the obesity. Modern obesity is indeed a disease of modernity, but regular old human primate annual metabolic changes involve times a year where you put on more weight, times a year you lose, farmers after harvest, but more importantly, animals the world around during dry seasons, wet seasons. It is normal to put on a certain amount of weight. It is normal for your fat tissue and the fat cells in them to expand to some extent during certain times of year. And in order for the cells to get bigger, they're in this whole matrix of extracellular protein scaffolding holding them in place. And for them to get bigger, you got to remodel the matrix on the outside there, and that's where the mild inflammation comes in. It is only with extreme modern pathological obesity that you get way outside the range of normal annual fluctuations, and fat cells get so big that they cause cellular stress, they cause activation of the neighboring inflammatory cells. You get into trouble that way. What we finished up with was a dichotomy between fat that is deposited in your trunk, truncal fat, visceral fat, fat that surrounds your organs, fat which metaphorically, makes you look like an apple versus fat, which is deposited in your gluteum and your rear end. And what you get there is pear-shaped individuals. And what we saw was the health problems derived from extreme obesity are coming from the truncal fat, because that's the fat that's surrounding your organs. So when inflammatory stuff is happening in that fat, that's what's being affected there. More innocent bystander consequences. Moreover, truncal fat tissue has more inflammatory cells than gluteal fat tissue. And moreover, interesting detail warm to my heart, fat cells, truncal fat cells, are more sensitive to stress hormones, have higher levels of receptors for glucocorticoids, so that stress has more of an impact, damaging impact on fat there rather than gluteal. So what Stephen is asking is, there's this weird phenomenon that's been floating around in recent years of metabolically healthy obesity. The fact that there's tremendous variability among individuals who are formally overweight by body mass index that fall in that category, tremendous variability as to how much ill health there actually is that accompanies it. Within the overall picture that obesity is associated with bad health outcomes, there's a subset of individuals who appear quite healthy. What are the markers of what is termed metabolically healthy obesity? You don't see elevated blood pressure in these individuals. You don't see hyperglycemia, elevated blood glucose levels. You see normal sensitivity to insulin. And these are individuals who are metabolically healthy. Who are these folks? And this is exactly as was being guessed at in the question. This was a recent review on this in the journal Endocrine Reviews, which is one of my favorite journals. I look forward to each new issue, and this was a review on metabolically healthy obesity. And it was nicely pointing out exactly what makes sense. For the same degree of obesity, people who tend to be metabolically healthy are the ones where it's predominantly gluteal fat, pear, rather than truncal. Moreover, it is fat that's more readily expandable during the seasonal increases and decreases in fat stores. In other words, requires less inflammation to do this remodeling. This is the profile that is healthier. Final important proviso, though, and this review goes out of its way to emphasize this, which is being metabolically healthy obese is not the same thing as being metabolically healthy when you are lean. You are doing much better than the typical picture of obesity. Nonetheless, this is still not a great profile. Nonetheless, this is not as good as you see in lean individuals. And importantly, this is a transient state. This is a state rather than a trait, which is somebody who could come out as being metabolically healthy, yet obese, may not be healthy some years from now. It is not something that should be ignored. It is simply a less extreme version of the health consequences of modern obesity.
Our final question today is there a neurological explanation for feelings of déjà vu or precognition?
Deja vu. It's the best. I love deja vu. Its incidence tends to go down with age, and I've been feeling it. I can't remember the last time I got a sense of deja vu, which is too bad because it's great for those of us who spent the 60s and 70s studying neuroanatomy rather than altering our minds pharmacologically. It's like the closest you get to being able to say, oh, wow, groovy. I'm having incredible deja vu moment. Deja vu, first discussed by a 19th century French philosopher named Émile Bouac, I believe is how it's pronounced, and people beginning to note it as a very special category. Okay, you got recollection. I have seen this before, and here's where I saw it, and here was the context, and here was the circumstance, recollection. I've seen this before. I can't tell you where or when, but I know I've seen this before. Familiarity. Recollection versus familiarity. Deja vu is neither of those. Deja vu is familiarity where you were conscious that you could not have seen this before, where you were consciously aware of the inappropriateness. This is what deja vu is about. Most people have it at some points. Again, as noted, it becomes less common as you age. Another feature of it, you don't walk in and look at somebody's shoe and say, oh, I'm getting deja vu. I've seen those shoes before. It just feels, I know I haven't, but it's not for objects and not for subsets of a whole picture. It's for entire scenes that you get the sense of deja vu. Okay, so what is it about? Not easily studied. Right off the bat, you know there are not going to be animal models for deja vu. It's not clear if animals would have it, this sense of this seems familiar, but I know it can't be. And presumably it's not been very frequent that some rainforest monkey is getting a sense of deja vu. Oh my God, I've these leaves. These leaves are, I just feel like I've been here before, but I know I've never seen these 10,000 leaves before. Go study it, go show it's there. It's not likely. Go study it in humans, and it is difficult as well because it is hard to study what's going on in somebody's brain when they're having a deja vu experience. It's rare. Some work, experimental work, on inducing a sense of deja vu in people. And two interesting approaches with it. The first one is somebody's looking at a film of a scene or something, and you flash up a different scene. You flash up a different image for a fraction of a second, for 35 milliseconds, for 35 thousandths of a second. That is way below the level of conscious awareness, not only of what you've seen, but even that something flashed up. That is way below the level where you see activation of upstream visual cortical areas that are processing it. And in a subset of individuals, about 40–50% of people, later on, you show them a picture of the thing was flashed up instantly, or you take them into a room that was what the picture was for a fraction of a second take, and they get a deja vu experience. This is weird. I know I've never seen this before. I've never been in this room before, but weird, cool, I'm getting deja vu. This seems familiar. So that is one way of inducing it. The other way, the other experimental paradigm has been the work of Anne Cleary at Colorado State University, where what she does is show people a series of pictures, drawings, whatever, and some of them have very distinctive configurations in the picture. For example, a picture of something with a long, long hallway, a picture of something with something runway-ish and something taking off from there, something with a strong structural feature to the picture. And what she then sees is a week later, you show them pictures, not the same pictures, but pictures with some of the same structural configuration, a picture of something else with a long hallway, a picture of something else where rather than an airplane taking off at the horizon point, it's a dragonfly taking off with something looking runway-ish. And most of the time, people say, whatever, no, I've never seen this before. Most of the time, this doesn't remind people of anything. Some of the time, it reminds people of, oh, this reminds me of that picture, one of the ones you showed me last week, but at a higher than expected rate, you instead induce a sense of deja vu in these individuals. This is I know I've never seen this picture, this place. I've never been, but it's feeling familiar. So it's possible to evoke it in people. Now, where most of the research on deja vu has come from is in the neurological realm, having to do with the fact that there are two neurological disorders that are associated with high rates of people having deja vu. Individuals with certain types of migraines and individuals with what's called temporal lobe epilepsy. And it's this last category that's been studied the most. Really nice work by Stephen Kohler at the University of Western Ontario, people with temporal lobe epilepsy. There's all sorts of different types of epilepsy initiating in different parts of the brain. Temporal lobe epilepsy, one of the more common forms, comes from the temporal lobe, and there's a number of very interesting brain structures inside there. It is a very frequent location where epilepsy starts, where there is a spot, an epileptic focus that begins neurons firing way faster than usual in a synchronized wave pattern of what constitutes an epileptic seizure. So individuals with temporal lobe epilepsy have particularly high rates of deja vu in the auras, in the 30 seconds or so before they have a seizure. So, why is that giving us a lot of insight? Because you can get a sense of where in the temporal lobe is there epilepsy initiating, where is the epileptic focus, and you could begin to see, aha, it's when the focus is in this part of the temporal lobe that you see the increased incidence of deja vu as opposed to that part. What are the parts that are relevant? In your temporal lobe is your hippocampus. And hippocampus is about memory. Hippocampus is about recollection. And when you were recollecting something, that's where you're getting hippocampal activation. When you were getting seizures, starting in the hippocampus during the aura and the 30 seconds or so before, you get recollection of specific memories rather than deja vu. This is familiar, but I know this isn't possible. This is more the hippocampus. Underneath, surrounding the hippocampus, are two regions. One is called the perirhinal cortex, and the other one is called the entorhinal cortex, and they are feeding information straight into the hippocampus. When you look at where the epileptic foci are, it's perirhinal, entorhinal cortex of the temporal lobe. That's where seizure foci are most associated with deja vu. And when you begin to look at the functional differences, hippocampus is about specific recollection. Perirhinal, entorhinal is about familiarity. And it's often perirhinal, entorhinal that then has to filter its stuff into the hippocampus for the hippocampus to then turn familiar. I know I've seen this. This seems to into specific recollection. Oh, that's right. This was the context. This is when it happened. This is the specific information. So a relationship between the two where the familiarity coded for in perirhinal, entorhinal, when it does result in a specific recollection, is often by way of the information being shunted. So seizures starting in this perirhinal, entorhinal, that's where you see the deja vus occurring at a high rate. Another way in which this is seen in the context of epilepsy, often when you have somebody with intractable seizures, where you need to go in and remove the epileptic focus in there because the drugs aren't working, neurosurgery, what is done beforehand is exploratory surgery to go in with electrodes in areas in the neighborhood, stimulate, and see what's being evoked. So at least you're going to get a sense of, oh, the spot with the epileptic focus is mediating something really important, really unique. Let's try to get the minimal amount of tissue out. It's just setting you up for doing the surgery most successfully. So you go in preparatively and electrodes around there and stimulate, and you find when you stimulate in the hippocampus, you don't particularly evoke deja vu in the individual. The individual who is awake at the time, something we've talked about, the brain itself does not have pain perception, is not sensitive to pain. Your scalp, your skull sure is, but once you anesthetize those and get in there, you can be probing someone while they're awake and you stimulate the hippocampus. You don't particularly evoke deja vu. You stimulate perirhinal, entorhinal, and that's where you got about a 5-fold increase in the incidence of people at that point experiencing deja vu. So this has given us some insight into it. Deja vu, why some individuals more than others, who knows what, why does it decline with age, who knows what, very importantly, qualitatively, is the deja vu in somebody just before they have a seizure or onset of a migraine the same sort of deja vu as in everybody else on those rare occasions. Nobody can study that. One final pathway that may be involved in deja vu, and this is one that's been around for some decades, and this is one of my favorites, in fact, because it is charming and makes perfect sense. Okay, visual information. It goes to your visual cortex in the back of your head, and it does boring, simple stuff like detect pixels of light and turn the pixels into lines and the lines into multi-dimensional stuff, and then eventually hands it on to parietal lobe and temporal lobe to do more interpretive stuff with it, to begin to say, this is this individual. This is something threatening. Let's tell the amygdala, where you do the more interpretive things going on. So you're sending this simple level of visual information up to these areas. You would think it goes in one single projection. In reality, though, it goes in two separate streams of projections. One stream carries the objective information about what you're seeing. The other stream carries the emotional connotations of it, which can include familiarity. So you get all these odd neurological disorders, Capgras delusions, which I think we've talked about. You get stroke damage to the familiarity one, and you recognize this is the face of a loved one afterward, but they don't seem familiar. They just don't seem right, and thus they're an imposter. Delusional responses to this. So in this case, what there's some evidence for is these two streams that, among other places, are projecting to the perirhinal and entorhinal cortex. These two streams should operate in perfect synchrony. And the theory has been that what deja vus are about is when the familiarity branch gets there before the objective information branch does. So that by the time the objective information, this is what I'm seeing, you already have a sense of familiarity with it, as if you have already seen it in the past. Simply the information has arrived earlier, all of this playing out in fractions of seconds. So that has been another possible pathway to it, and I find that one to be particularly interesting. The familiarity gets there before the objective recognition, the objective data as to what you're looking at gets there, so that by the time it gets there, wow, I know I've never seen it, but it feels familiar. And my bet is that's one of the major mechanisms for deja vu.
That's it for episode 85. I'm Offspring Sapolsky, and thanks for your continued support of science and the beard.